So today we're going to talk about logarithmic differentiation. And what logarithmic differentiation is it is a tool in which we can take the derivatives of functions by using the properties of a logarithm. So one example where this is going to be useful is in trying to find the derivative of the function x to the power of x. And the technique here is first to take the logarithm of both sides, and then to take the derivative, and then basically to kind of see what happens and find the derivative that way. So that's exactly what we're going to do. So the first step is that we need to take the logarithm of both sides of this equation. So if we take the natural log, and typically when I say take the logarithm, the log that we want to use is the natural log, we're going to get something like this. And if we remember our logarithm properties, if I have the natural log, or really any log, of x to some power of n, what we can do is we can actually just pull that n down and basically write this as n times the natural log of x. Again, this is just a logarithm rule from pre-calculus, so we have done no calculus thus far. So if we do that, we're going to be left with the natural log of f of x on the left-hand side, and then we're going to be left with x natural log of x on the left-hand side, because we can pull this x, or on the right-hand side, because we can pull this x down. Okay? So now what we want to do is take the derivative of the left-hand side and the right-hand side. And you'll notice here that while we really didn't know how to take the derivative of x to the power of x, we can take the derivative of x, natural log of x, by using the product rule. So we're just going to focus on the right-hand side first here. So the right-hand side is going to be, remember that if you have a u and a v here, you want to take u prime v plus u v prime. That's the product rule. So we're going to take u prime, which is x, or the derivative of x, which is 1, times the natural log of x, so that's u, and then v prime, and then plus x, and then what I want to do is I want to take v prime, the derivative of natural log of x, which we know is 1 over x. And as you can see, the x's here will cancel, so this is just going to be the natural log of x plus 1. Okay, so now if we consider the left-hand side of this equation, well, if I say what's the derivative of the natural log of some function, well, last time we saw that if we wanted to take the derivative of the natural log of some function, that's going to be the derivative of that function divided by the original function. So we'll just bring this down. And now what we're going to do is we're just going to rearrange this and solve for f prime of x. So notice if I multiply both sides by f of x, I'm going to be left with f prime of x equals the natural log of x plus 1 times f of x. So this is going to be the natural log of x plus 1. And now f of x, if we kind of look back up here, we said that f of x was x to the power of x, so we can just substitute that here. And this will then be our derivative. So you'll notice that this is kind of almost a little bit of an indirect way of finding derivatives. This actually turns out to be an example of something that is known as implicit differentiation, which we will talk about in more general in our next section. But as you can see, this is very useful for finding derivatives of functions like the one that we just did. Now, let's just do one more example. And in the last example with x to the power of x, we really didn't have any other means to find the derivative of a function like that, except perhaps maybe by using some kind of limit law type of situation, which would have been rather complicated. So this example here is something that we could directly find the derivative of simply by using the product rule, the quotient rule, and the chain rule all in one go. But as you'll notice here, this is something that's actually rather complicated. And because it's rather complicated, you'll notice that the logarithmic approach to this problem will actually be significantly easier. So just like before, we're going to take the natural log of both sides. And when we do this, we will be left with the following. And I'm actually just going to convert the denominator here to the 1/2 power because I think it'll make things a little bit easier as we go forward. Again, when I consider this right-hand side here, you're going to notice that we have a product, we have a whole bunch of we've got some exponents involved, and we got a couple other rules of logarithms. So if you remember correctly, if I have the log, and I'll just use capital letters here, of something that's a times b, well, that's going to be just the natural log of a plus the natural log of b. Again, this holds for every logarithm. And likewise, if I have the natural log of, c over d, for example, that's going to be the natural log of c minus the natural log of d. And we also have that other property that if I've got the natural log of, say, a to the power of n, that's going to be n times the natural log of a. That's what we did last time. So using all of these rules together, what we can do is we can actually break this into a sum and difference of logarithms. So the way that I'm going to do this is we're going to take basically this guy here. We're going to take the log of this guy, the log of this guy, and then subtract this guy down here, and then we're also going to pull these exponents out. So I'm going to do this in one big step. So this will just be 2 times the natural log of x plus 1 plus the natural log of x squared minus 3, and then minus, and then we're going to pull this 1/2 out, the natural log of x squared plus 1. Again, I'm not going into a lot of the details and logarithm rules here, but again, perhaps at a later time I will create a video that explicitly explains all of these rules. And again, this is kind of a pre-calculus topic, so again, if I ever get around to making pre-calculus videos, I'll be sure to do this in more detail at that time. This is just going to be the natural log of f of x. And then, of course, we want to take the derivative of each of these sides here. So the left-hand side will just become f prime of x over f of x, just as I said before. And then the right-hand side, remember the rule here is that I just take the derivative of the inside function and divide it by the original function. So 1 is the derivative of x plus 1 over x plus 1 plus, and then this will be 2x over x squared minus 3. So again, all I'm doing here is looking at these guys and taking the derivatives, minus 1/2, and then 2x over x squared plus 1. Okay. And then from here, we can actually just multiply both sides by f of x. So f of x, f prime of x will be this times whatever f of x is. And then since we already know that f of x is this up here, we're just going to substitute in for f of x there. So this will be x plus 1 squared times x squared minus 3 over the square root of x squared plus 1. So that is how we can use logarithmic differentiation for a more complicated problem. And again, this will be the derivative. Keep in mind, of course, that if you take the derivative of this directly, this won't be in the factored form that you see down here, so it might be in a slightly different form, but it should be equivalent to what we have down here. So that is it for logarithmic differentiation. As always, I hope that you find this video helpful, and take care.